What happens to information when it falls into a black hole? According to some quantum mechanics, nothing can escape from a black hole, not even information. In this video, we will talk about some fascinating facts about the black hole information paradox. Don't miss out on the entire video. When we talk about information in the context of the information paradox, we aren't referring to everyday information like facts in a book or data on a computer. Instead, we're talking about the quantum state of a particle or system. Every particle can be described by a specific quantum state. This quantum state provides all the details you'd need to predict the outcomes of measurements on the particle. The principle of unitarily in quantum mechanics says that information is never lost. It just evolves over time. Now, let's say you're feeling adventurous and decide to throw one of your notebooks into a mysterious cosmic blender called a black hole. Normally, you'd expect the information in your notebook to be safe and sound, just rearranged inside the black hole. But here's where the puzzle begins. According to our current understanding of physics, when a black hole eventually disappears, it seems to take all the information inside it with it, like your notebook vanishing into thin air. This contradicts the fundamental rule in physics that says information can't just disappear. It should always be conserved, even if it changes form. Because the universe is the ultimate info keeper. It's not interested in making fresh data or throwing any out. It's like a cosmic librarian that says, "I'm keeping it all." Now, scientists have done some serious cosmic detective work, and it turns out that, information in the universe has a no-quit policy. It's here to stay. First, let's tackle the concept of information and why it's so crucial to preserve it. You see, physics operates on a fundamental principle called determinism, which means we can use the laws of physics to predict how a system will behave in the future. That's essentially what physics is all about, predicting the future based on the rules of the game. Whether we're dealing with a single particle hanging out in a box, a complicated chemical reaction, or the entire universe itself, our understanding of physics lets us make rock-solid, dependable predictions that take us from the present into the great unknown of tomorrow. Now things start getting really cool. We can also look into the past by using the same trick to make things predictable. If we know everything there is to know about a system, like where all the particles are and how fast they are moving, as well as their spins, electric charges, and all the other small details, the rules of physics give us the power to turn back time or speed it up. Like a cosmic DVR, we can see exactly how that system worked in the past and how it will work in the future. We think that information stays the same because of this magical power to go back and forth in time. Imagine this. If I know everything there is to know about a system, then the constant rules of physics tell me exactly how all the particles will behave no matter when I look. So all of the raw, unfiltered information about that system stays around as time does its thing. It does not appear or disappear. It is more like a cosmic book that keeps getting changed, but the words stay the same. At first look, black holes seem like they do not care much about information. Things and the information about them fall into these huge cosmic things. From a safe distance, it seems like nothing ever really falls into a black hole. Instead, it seems like things sort of stick to the top of the black hole. Now, it is a little more complicated than that, but this simple explanation is enough to understand the problem we are in. This whole situation is not too bad for information, though, because information is not supposed to be made or broken, it is just supposed to be around. That is, until the black hole starts to disappear, which is where the puzzle starts. Stephen Hawking found out in the 1970s that black holes are not really black after all. This was a big deal. They give off a very small amount of energy. Hawking radiation is exactly what it sounds like. Random heat, like the heat your body gives off. This radiation is purely thermal, which means it's solely determined by the black hole's mass, spin, and charge. Nothing else matters. It doesn't matter if you toss books, cats, or even spaceships into a black hole. Its Hawking radiation stays the same. Now, here's a zinger. Maybe Hawking radiation, which we thought we had figured out, isn't all it's cracked up to be. Perhaps the information that clings to the black hole's surface somehow sneaks into the radiation it emits. This would be a game changer and would keep our existing physics intact. But here's the hitch. We haven't figured out how to actually pull this off yet. It's like saying we can reconstruct lost books, cats, and spaceships from random notes, but the actual process remains a mystery. Or perhaps information doesn't stick to the surface, but leaves a little nugget behind as the black hole vanishes. Sounds neat, doesn't it? Yet, once again, we're in the dark about how this would function. Now, Stephen Hawking also found something very interesting. Information could not stay stuck in black holes forever. It seemed like a lose-lose situation because it could not stay in the black hole and could not ride out with the radiation. So did that mean that it was going away for good? Well, keep your cosmic thinking caps on because a group of scientists has a different view. In a study that was recently released, these scientists came up with a clear no. Their answer has something to do with the idea of bald black holes. A while ago, the same group of researchers suggested that black holes were not actually bald but had something they call quantum hair. Think of it as a unique quantum mark left by the way black holes bend space-time at their edges, showing where the stuff inside came from. In essence, the missing knowledge was in this hair. When the idea of quantum hair was first brought up, it was more of a mathematical thought. But in their most recent study, they say that this hair is the key to solving the whole paradox. The twist is that they went back and looked at Hawking's original findings, which said that black holes only gave off information-free thermal Hawking radiation. But this time, they added something very important: quantum gravity. Hawking had not thought about this before, but this is how gravity works in the quantum world. The study was led by a physics professor, Xavier Calmet. He said that even though these quantum gravity effects are very small, they are important for black holes to disappear. Their study shows that radiation can carry information when quantum gravity is taken into account. In other words, Hawking radiation could pick up information from black holes and send it out into the universe if these quantum gravity changes are made. The information that was saved in the quantum hairs around black holes might be able to get out. Honestly, we're in a bit of a cosmic conundrum when it comes to the black hole information paradox. But here's the thing. That hasn't stopped imaginative physicists from dreaming up a whole bunch of possible solutions over the years. Another possibility is that information actually hangs around just fine. Sounds simple, right? Well, not exactly. This would require us to essentially rewrite the rulebook on almost everything we know in physics. It's like saying, hey, let's change the game, but just for this one unique situation with black holes. Is it worth the effort? Some argue yes, especially because black holes are such captivating cosmic puzzles. Plus, hey, we've tweaked the laws of physics before, so it's not entirely unprecedented. Now hold onto your space helmets, because it could get even wilder. Maybe the information takes an interdimensional vacation, getting funneled into another universe, or even doing some time-traveling shenanigans. What is so interesting about this paradox is that all of its possible answers point to new areas of study in physics. So whether we solve this cosmic puzzle or not, we are in for a mind-expanding journey of learning about the world. One thing is for sure. It is like trying to solve a huge puzzle whose answers promise to be a great trove of information. Do you think information can truly vanish into a black hole, or is there a hidden cosmic secret waiting to be uncovered? Share your insights in the comments below. And if you're hungry for more mind-expanding content about space, time, and the universe's deepest mysteries, don't forget to subscribe.